Science is such a wonderful utilization of knowledge and comprehension on our surroundings. With science having variation of field, each discoveries, theories, and inventions were placed in such fields. Physics is one of it. Physics is a fascinating realm of science. It helps us understand how everything around us moves from its trajectory, speed, and distance.
Many pioneers have ushered out over hundreds of years that culminates our very knowledge about physics today. Some of them made huge discoveries that innovated our understanding around the world. People would know who Galileo Galilei is, Albert Einstein, and Isaac Newton, and many more scientists that have become the foundation of science.
Dr. Chien-Shiung Wu, a pioneering physicist, earned various nicknames such as the First Lady of Physics, the Chinese Marie Curie, and Madame Wu. Best known for her contributions to the Manhattan Project and her groundbreaking cobalt-60 experiment challenging the conservation of variety. Her work remains a standard in physics today. She was born in Dhenyze, China in 1912. Chien-Shiung Wu defied societal norms to pursue education, inspired by her father. After excelling in school, she attended National Central University, drawing inspiration from scientists like Marie Curie and Jane Gu. Gu encouraged her to pursue further studies in the United States, leading Wu to the University of California, Berkeley, where she earned her PhD in nuclear physics under the guidance of Ernest Lawrence. In 1942, Wu married fellow physicist Luke Chia-Liu Yuan and moved to the East Coast. Despite anti-Asian sentiments during World War II, Wu's relocation opened new opportunities, joining the Manhattan Project at Columbia University in 1944. She played a crucial role in uranium isotope separation, contributing significantly to the development of atomic weapons. In 1956, Wu collaborated with physicists Zhong Daoli and Chen Yang, conducting experiments that contradicted the conservation of variety. Although Li and Yang received the Nobel Prize, Wu's pivotal role is often referred to as the Wu experiment. She continued her research at Columbia, delving into medicine and contributing to the understanding of sickle cell disease.
The Wu experiment was a particle and nuclear physics experiment conducted in 1956 by the Chinese-American physicist Chien-Shiung Wu in collaboration with the Low Temperature Group of the U.S. National Bureau of Standards. Before Wu's experiment, it was widely believed that certain fundamental processes in this particle physics, such as beta decay, followed by the principle of parity conservation, this means that the mirror image or reflection of a physical process would be indistinguishable from the original process. However, theoretical physicists Zhong Daoli and Chen Yang proposed that the weak force responsible for processes like beta decay might violate parity. Wu designed and conducted an experiment that involved the beta decay of cobalt-60 nuclei. The results of her experiment confirmed that parity violation did indeed occur in weak interactions. The experiment established that conservation of parity was violated by the weak interaction, providing a way to operationally define left and right without the reference of the human body. This result was not expected by the physics community, which had previously regarded parity as a symmetry applying to all forces of nature.
We will now dive deeper into how the Wu experiment was conducted and how such conclusions were inferred based on the results of the experiment.
Wu chose cobalt-60 as the source material for beta decay. Cobalt-60 is a radioactive isotope that undergoes beta decay. The cobalt-60 nuclei were polarized, meaning their spins were aligned in a particular direction. This was achieved by subjecting the cobalt-60 to a strong magnetic field. Due to the polarization, the emitted beta particles would preferentially be emitted in a specific direction, rather than isotopically. Detectors were placed in specific orientations to measure the beta particles. goal was to observe if there was any preferred direction in which the beta particles were emitted. If the wave force followed parity conservation, the beta particles should be emitted symmetrically in all directions. Contrary to expectations based on parity conservation, the experiment revealed a significant anisotropy, or direction preference, in the emission of beta particles. The experimental results provided strong evidence that the weak force violates parity conservation. This supported the theoretical work of Li and Yang, who had proposed that the weak force did not obey parity symmetry.
Wu's experiment was groundbreaking because it directly tested a fundamental symmetry principle in particle physics. The unearthing of this phenomenon laid the foundation for the formulation of the Standard Model. This model hinged on the concept of symmetry within particles and forces, exploring instances where such symmetry could be disrupted. The widespread recognition of her discovery prompted author Robert Frisch, the discoverer of fission, to assert that many at Princeton regarded her findings as the most significant since the Michelson-Morley experiment that inspired Einstein's theory of relativity. AUUW labeled it the solution to the number one riddle of atomic and nuclear physics. Beyond illustrating the unique nature of weak interaction compared to the three other conventional forces, it eventually paved the way for general CP violation, signaling a breach in the charge conjugation parity symmetry. This violation allowed researchers to differentiate between matter and antimatter, providing a framework to elucidate the universe's composition predominantly made up of matter. Wu's discovery would pave the way for a unified electroweak force that Salam proved, which theoretically described to merge with the strong force to create a total new model and a grand unified theory.
With Dr. Wu's partnership with Chungdao Li and Chien-Shiung Yang unexpectedly unearthed the violation of the conservation of particles. Only Chungdao Li and Chien-Shiung Yang were accepted to claim the Nobel Prize in Physics in 1957 because they provided the idea of the experiment and theorized the parity non-conservation. While not awarded the Nobel Prize, Chien-Shiung Wu's role in the discovery was mentioned in the Nobel Prize acceptance speech of Yang and Li, but was not honored. Wu was honored with many other accolades throughout her career. In 1958, she was the first woman to earn the Research Corporation Award and the seventh woman elected to the National Academy of Sciences. She also received the John Price Wotherell Medal of the Franklin Institute of 1962, the National Academy of Sciences Cyrus B. Comstock Award in Physics, the first woman to receive this award in 1964. The Boner Prize of 1975, the National Medal of Sciences of 1975, and the Wolf Prize in Physics Inaugural Award in 1978. She was the first woman to receive a Doctor of Science degree from Princeton University in 1958 and was awarded many honorary degrees. In 1974, she was named Scientist of the Year by Industrial Research magazine, and in 1976, she was the first woman to serve as president of the American Physical Society. In 1990, the Chinese Academy of Sciences named asteroid 2752 after her. She was the first living scientist to receive this honor. And 5 years later, Chungdao Li, Chien-Shiung Yang, Samuel C. Ting, and Yuan T. Li founded the Wu Sheng Education Foundation in Taiwan for the purpose of providing scholarship to young aspiring scientists. Wu retired in 1981 but continued to inspire future physicists through educational programs. Regarded as a heroine and the greatest female Chinese scientist of the 20th century, Wu's legacy endures. In 1990, an asteroid was named after her, and post-retirement, she focused on encouraging women in science. Dr. Chien-Shiung Wu passed away on February 16, 1997, leaving an indelible mark on the world of physics.
Dr. Dr. Chien-Shiung Wu was one of many scientists who were shunned upon their scientific endeavors and discovery due to their circumstances, yet they still continue forward making the world a better place and improving vast knowledge of the world while making little to no acknowledgement from the world. Dr. Wu's achievement and trailblazing were a stepping stone for physics. However, very few young minds only know of her contributions in the world.
Dr. Chien-Shiung Wu's accomplishment might have started to fade away from the presence of the world. Her legacy that left for scientists to nurture will never lay to rest.
As Dr. Chien-Shiung Wu once said, Beta Decay was like a dear old friend. There will always be a special place in my heart reserved specially for